Hi class, so the next lesson that we're going to have is about iterators and generators. So the different iterators. Before we talk about iterators, there's different objects that we can iterate. So something that we can iterate is called a iterable. So for example, a list is iterable because we can iterate through every single element. A string is a iterable because we can iterate through every single character. A dictionary is a iterable because we can iterate through every single element. And a file is a it's a iterable because we can iterate through every single element. So let me show you guys an example. Let's do so one of you guys um, go to the section on your Replit that says iterators and generators for the lesson plan, for the video lesson. And so what I do here, you should be able to write it out and you're going to be able to submit that as part of your work. You're going to turn it into PDF. You're going to copy paste it, put it into a file, your favorite file type, your favorite type file, and then you're gonna be able to paste it and save it and then submit that as your work. Now here we're using a Replit, so make sure that you follow the instructions to be able to create your account on Replit. And so Replit is different than what we were using with the collab. And so a collab, you can actually see the result at the moment that you actually write in the line of code. So it's an instance it's an instant return code collab, verification code, right? And this one is this will actually run every single line of code and then we'll show you what your work is, right? What your final product is. But let's create a list. So for example, I want to show you that a list it's iterable, right? So for s in the set, I'm just gonna make the set right now. Apples, oranges, apple, oranges, bananas, and pineapple. So here we create this list, and I want to show you that we can iterate this list. So right now, if I run this part, I'm gonna be able to display every single element of my list. As you can see, we're able to see apples, oranges, bananas, pineapples, right? So you can see that the list is iterable, meaning that we can iterate through every single character. Now that's a list, example of a list that it is a iterable. Here's an example of a string that is iterable that we can iterate. So for example, we can do the same thing for C in the word hello world. We can iterate through every single character. and you will see that we can display we can go through every single character of the word hello world, right? And then we can also iterate, we can say that a dictionary just say we can iterate over a dictionary. So let's say that we have 4K in the dictionary, X1, Y, 2. Sorry, that's a typo. And then we can print the key of our dictionary. You can see that we're printing the keys of our dictionary, the X and the Y. Okay. So again, these are called iterable objects, right? So a list is an iterable object. String can be iterated. We can say that it's an iterable object. We can iterate it through a direction. So that they're all saying the same thing. So those are examples of objects that are iterable. And so now we could, so we could use an iterator to be able to iterate through every single object of our iterator. So remember, it an iterable object means that you can go through every single element of that object. So for example, the list, the string, dictionary, file, right? You can go through every single element means that's an iterable object that you can go through every single object. Now we can use an iterator. So the way you want to think about an iterator as a helper that is going to help you to iterate through every single element of your iterable object. So we can create an iterator for an iterable object which is built in with a built-in function iter. Then we can use the next function to get values at a one at a time. So what we're saying is that we can go through every single element of your iterable object one at a time using an iterator. So it's an iterator, it's a function that we can use to be able to go through every single element. So let me show you guys an example. So think of iterators as helpers to get through the elements of your iterable object. So it's like a helper. It's gonna help you go through every single element. So let me show you guys here. So let's say that I want to create an iterator. So I'm gonna creating an iterator. So what I can do to create an iterator, I can use a function iter. So I'm gonna call x equals my iter function. So by using the iter function, we're gonna create an iterator of whatever iterable object we're gonna have. So I'm gonna pass in an iterable function, or sorry, an iterable object, which is 1, 2, and 3. That's an iterable object, that's a list, right? Remember? Okay, remember we're using a iterable object and we're gonna create an iterator. So right now this is going to be an iterator. So we're creating this iterator to iterate through the object 1, 2, 3. So remember, this is a helper. This is an iterator. Right now, X is an iterator. In order to go through every single element, I can use my method next to grab every single element of my iterator. So we need to use the method next to access every single element of my iterator. So notice that I'm going to be able to run this and be able to see my first element, which is 1. Maybe I should have something like print and that makes it easier for us to see. Right, and then I'm going to do the same thing here. Copy. And I'm going to put a string there to emphasize that we're iterating through a string. I'm going to put some backslashes in the back so that way we can separate the first statement from the second one. And then we can do something here. Oh, sorry. So we can, again, comment this, and we can say that we're talking about an iterate over a dictionary. Now we're talking about a iterator. And we're creating an iterator. That way it's easier for us to see it in the in the console. We can see the iterable, right? The list is an iterable object, string is an iterable object, the dictionary is an iterable object, we're iterating to the dictionary, it's an iterable object, right? And then here we can see we're creating an iterator using the iter to go through every single element. So this is to get one element. Now to get the next element, I have to call the method again next. X, notice I'm just calling that function again, and that will give me the next element. You can see the 2. If I want to grab the next one, I can keep doing that process and grabbing the next element. And that will return the next value. Notice that I have to print it because otherwise we won't be able to see it. So, but I can actually, this would return next X right here. Next X is returning the value 1. And then if I call that method again, I will return the value 2. And if I call it again, I will be returning the value 3. Right? So again, an iterator, right? So we're making an iterator. X is my iterator. So my iterator allows me to go through the elements of my iterable object. So this is like the iterator that we were talking about. I don't know if you have taken my data structure class, but in a sense, right? This is the object iterable. Now, an iterable uses what we call iterator. And then the iterable could be a sub, it might have a sub interface like a list, which is the iterable list, or a dictionary, or other things, right? But so an iterable it uses an iterator to be able to go through elements, right? Or you don't need to use it, but that's the idea, is that an iterable uses an iterator. Like hopefully that gives you an idea what the difference between an iterable and an iterator. Okay. Now what we want to do is we're going to move on to the next part. I'll show you guys an example of an iterator. Notice that if I call this one more time, it's going to say that we are that we need to stop the iteration, that we're beyond the capacity, right? So you can see that it's going to throw an exception, right? Because we are beyond the value of our iteration, right? So we don't have any more elements. So this will crash the system. Right? And then we can move on. So now we know what an iterable is and what an iterator is, right? Iterable versus iterator. Remember, a iterable object is something that you can iterate, right? A list is an iterable. All right, good. So now let's move on to the next slide. So we can create our own iterators using a class. So not only do we can we just use the iter function, but we can create our own iterators if we want to. And we can, so that following iterator behaves like a range function. So we're going to create an iter method that makes an object iterable. Behind the scenes, the iter function calls the iter method of on the given object. So let me show you guys that. And then we're going to return the value of the iter as an iterator. It should have a next method and erase stop iteration when there are no more elements to go through. And then we want to erase that erases means to call an exception, which can be caught in a try and except block. So when we create our iterator, right? Remember when we create our iterator that's going to iterate through some values, we need to be able to create a method called iter, which is how to create our iterator. And then we need to define our method next to be able to access the next item into our object. So we're going to create our own iterators, okay, as a class. So let me show you. So we're going to go class range. Let me call it my range. And we're going to define our initiator. So remember how to create a class, right? When we create a class, we need to have our initiator, which is how to instantiate an object. If you have taken Java, an initiator is like a constructor, right? It's going to allow us to be able to build that first object that we want. We also have to have a self attribute, and our n will be our attribute that allows us to be able to range from a specific value. So we're gonna start our value at initial, right? Our initial value will be I. We're gonna start at 0, and we're gonna end at n, right? So this is going to be a range, a value, a class that is gonna range from the value 0 to the value n. And depending on what the value is given when we create our constructor or initiator, that's how far we're gonna range. We're gonna range from 0 all the way to n. So this is our constructor. Now we're gonna create our iterator. So in the instructions, we're saying that in order for us to create our own iterator, we need to be able to instantiate our iter method. Now, this is something that we can override. This is a method that we're going to override. And we're going to return self. So practically, a method iterator is just gonna call on itself. That's why we're just gonna return itself. Now, when we need to be able to have our next method to be able to return the next value available. So some of you have taken data structures, and this might seem familiar. Remember that an iterator has two things to do, right? It can always provide the next item available, right? Right now we're doing an iterator, not a list iterator. There's a difference between an iterator and a list iterator, right? We're just keeping it so that we can always return the next item available. So just remember that this is very similar to having to do a data structure. So we're making our own class that can iterate through every single element. And now we don't need anything other than the next available item. So what we're gonna do is if self dot initial value is less than the self dot end value, we're gonna keep moving our I value. So we're gonna say our self I value, our I will be equal to the self I, and our self I will increase by 1. So we want to increase our value by 1. And then we want to return I. Remember, our self I will be increasing by 1. And we want our I value to be increasing. I'm going to return our I, else we want to raise, remember, we want to raise a stop iteration exception. So we want to go through every single element. If we reach the end, we want to throw an exception. So how is that going to work? So this is our class. And now what I wanted to do here is I want to make my range. So I want to say, let's make my range equal to my range that is going to go from 0 to 3. And what we want to do is we want to print what is our next item for our my range. So we're gonna call this is our iterator, and we're gonna call, remember just the way we did it before, this is our iterator for this iterable object. So what we're gonna do, we have this iterator that we're gonna call on the next method available. Let's make this, let's put it here, print. Say this is our build iterator class. So let's see how that looks like. So as you can see, the first element that we have on our iterator is 0. If I call this method again, if I call this line again, I will get my 0 and 1. And if I keep calling it, I will get my next element. And if I keep calling it, I will get our stop iteration. You can see that once we call it 4 times, we're beyond our iteration. So we're past our capacity. Remember, if we reach the value, the last value, which is 3, we want to be able to go and stop the iteration. So here we created our own our class that we created is going to have its own iterator, right? So we could make any class that we want, and we can define their own iterator. And but if we're gonna do that, we need to define their next method as well. So we could define an iterator for any class that we want. So that we have both options, right? If we know that this is an iterable object, we can we can make it into an iterator by using the iter function. Or if it doesn't, then we can make that object its own iterator. But you need to define the iter method and the next method, right? So those are inherit, so you have to override them. Okay, let's move on to the next part. So let's move on to the next one. Let's write an iterator class that will be doing the reverse iter that takes a list and iterates it in from the reverse direction. So we know we can make an iterator and print every single element in the forward direction, but let's do it from the reverse direction for a iterator. So let's build it. So what we're gonna do here is we're gonna make our own class reverse iter. Oh. And we're gonna define our iter again. Sorry, our initiator. So I could also define here none. So you can define what kind of return this will be. So you can do that. This is if you want to specify what kind of return data type you want to have. You can write it like that or not, but we'll get to that part. I will eventually talk about that. Let's just keep it simple for now, and let's just keep it the way we were having it before. So we're gonna create this uh uh object class, right, with this initiator. And what we're gonna do is we're gonna pass in a list. So we want to create a reverse iterator of a list. We're gonna call it LST for list. And what we're gonna do here is I want to save my LST to my data field LST. Right? So we're just gonna take this given by the user, right, when they pass in, and we're gonna save it as our data field. Now what we're gonna do is we're gonna create our iterator, right? So we're gonna make this iterator class. So iter, and again, it's gonna be the same thing. So this is always gonna be the same. We're just gonna return. Just gonna return self, right? We're gonna call it self. Sorry, return. And we're gonna do the same thing, but we're gonna iterate through every single element of our list. So we're gonna do it backwards. So we're gonna do if the length, oops, sorry, if the length of our list is greater than 0, we're going to return a self dot list dot pop. So we're gonna grab the last element of our list. Remember that pop on a list means that you're gonna return the last element of your list. So we're gonna keep removing an element from our list. So we're gonna keep popping the last element, and we're gonna return it. That's why this is going to return it in a backward order. And what we're gonna do is we're gonna raise a stop iteration once we reach the end. So this is removing the actual values from the list. Now let's see how that would look. So let's make this print. We're gonna print this is our build reverse iterator class. And what we wanted to do, we're gonna call it, I'm gonna call it reversed iter equals my reverse iterator, and I'm gonna pass in the list 1, 2, 3, 4, 5, or 1, 2, 3, 4. So we created this iterator, right? And we can pass in this list of as an iterable, and we can call that, we can print the next item of our reverse iter. Oops, sorry. So we created our own iterator that is going to act, that if you're given a list, is going to return the values one at a time. So let me take this off of here. It's going to return every single element one at a time from the reverse order. So what this is what the advantage of doing an iterator is, that it stops every single time. You don't get all the elements at once. So you can grab one element at a time. You can ask for one element. So you're iterating. And the next item, it just shifts to the next item available, and it's waiting for you to call the next method to return to you back the next item. And it's waiting for the method to call next to give you the next item. So it doesn't give you all the elements at once. So it's a nice helper to get through all the elements in your iterable. Right? So let's keep going. So Python, let's see. Right, so Python generators lets you create your own iterator function that returns the transversal object with the sequence of values. So so right now we've been creating our own iterators, but there's an easier way of creating our iterators instead of using the whole iter function that we were using right now. So you know how if we go here, we were using our iterator, and next to be able to create this iterator. But we can do it in a different way. There's a faster way of doing an iterator without using the iter in the next. And that's called a generator. So Python generator lets you create your own iterator function that returns transversal object with a sequence of values. In a general function, a yield statement is used rather than the return statement. So we're not going to use the return. Instead, we're going to have a yield. So it's like you're gonna put a pause to the next value that you want to return. So you're not going to return the value, right, all the values at once of your iterable object. You're just going to return one element at a time. So the return statement terminates a function entirely, while the yield statement pauses a function. So a return will give you all the elements at once, and it will terminate the function. But a yield will make a pause for the function and hold that state and continue your successive calls, your next calls. If we want to create an iterator, we can do it in the way that we just seen before, the way I just show you, or we can use a simpler method called the generator. A generator simplifies the creation of the iterators. It is a function that produces a sequence of results instead of a single one. So it's going to create this result that is going to give you one by one an element. So what we're going to do is we're going to take that myRange and make it into a generator function that produces the generator. Every time the yield statement is executed, the function generates a new value. So we're going to take the example that we did before, right? This example of myRange. And instead of using an iter and an next, what we're going to do is we're going to use a generator. Okay. So let's go down here. I'm going to copy this part right here. So we know that we're going to do this the same way, right? Now I'm going to erase all this. We don't need this information again, right? We're going to actually create this instead of using a class. We don't have to create a class. We can just use a function to do our definition, our new iterator. I'm going to call it myRange. and I'm gonna pass in the value n. So instead of using a class, I'm gonna use a function to create this generator. My value will start at I equals 0. Then while my I is less than n, I'm going to yield the result. And then I'm going to increase my value of my I by 1. So so this is my this is our um this is how we can build an iterator without a class using a generator. So to create a generator, all we have to do is use the word yield. So we replace the word return with the yield, that is actually using a generator. So yield, kind of like when you're driving and it says yield, it says that you're gonna make a pause and wait for the next, right? You're gonna wait for it, right? A little bit until the car, then if there's no car coming, then you're gonna go, right? But in this case, it yields until the method is called again. So let me show you guys, so let me show you how that works. So we're gonna create this iterator, my range equals my range 3. And I think this is gonna be confusing because we have let's go with G. Let me go with my range underscore my range 1. All right, so this is our range. Okay, so I'm gonna call the next method. So right now, if I print again, I want to use my next. It's an iterator, so I have to use my next method to access my element. So you can see here that I can access the first element of my iterator, building and using a generator. And I can repeat this process again, and you will return one element at a time. Right? So I can call the next one, and it's going to return the second element, and it's waiting for the next method to be called to return the third value, the next item, right? So just the way we did it before. And that's when iterator does. Remember, iterator just doesn't give you the values all at once. And you can see that it gives you a stop iteration automatically. It's already built there. So this is the fastest way to create a iterator using a generator. Okay. So let's see how this works internally with a modified generator function foo that has some extra print statements in it. When a generator function is called, it returns a generator object without even beginning to execute of the function. When the next method is called of the first time, the function starts executing until it reaches a yield statement. The yield value is returned by the next call. So let's show this a little bit more with the print value there. So I'm gonna make a full function. So we're gonna say definition foo just to make some random function. And what we're gonna show you is we're gonna see how where is the yield stop and what information is gonna return to you. Where does it pauses? Right? What part of the function foo does the function pauses and returns a value, right? So for I in range 3, we're gonna print before yield And we're gonna have I, right? Just to see what is the value of your I, right? In which part of your iteration you are at. We're gonna yield at I, and then we're gonna print after the yield of I. So you can see here, what we're trying to show is that it pauses your function at that yield. It doesn't go forward until it doesn't keep going on your function until you call the method again. So I'm gonna see here. There's a built-in iterator without the class without the class using a generator. Um, it's a built function iterator fo. Once we added the word yield, we're turning into an iterator. So let me show you. So let's call it f equals fo. And notice that if I call the method next f, right? This is my iterator. Oh, I gotta stop. I'm gonna pause this one. I gotta that it was causing it because I was going beyond the range. So you can see here that it shows our begin. So it's printing when we call that method our iterator, it's gonna print the beginning, it's gonna keep going, it's gonna print the before yield I, and then it's going to pause at your yield. Right? You can see here it's printing begin, prints before the yield 0, and then the yield, and it pauses right after it returns the yield. Notice that it didn't print the after I nor the n. But if I call this, I'm sorry, if I call the next, right? If I ask the iterator for the next item, you can see that it's going to print. So since I'm calling the next item, it's going to continue on the function, that means it's going to print the after yield I. It's going to go up to the for loop, and it's going to print the before yield I, and then it's going to return the yield. So you can see here the after yield 0, the before yield 1, and now it's returning the 1. So again, right now it is paused on the yield I. So it's not printing, it's not accessing this line yet. But if I call it again, it's going to it's gonna go ahead and go to the next item. And so it pauses again at 2 here. And then it's going to so it's waiting for the next yield, right? And so we can go ahead and call it again. If I call this again, it's going to be able to print the and, right? The last part of it that we need. You can see that it prints the after yield 2, and it finishes the whole thing. But if I try to go up again to call an iterator again, it's gonna crash the system because there's no more yield. I'm outside the iterator. So hopefully that gives you a perspective of how this yield iterator works, like why how the yield process the execution of the function. So it's put it on hold until you call the next method. It's a very powerful tool. So let's see more examples of generators. Using generators to create iterators, like integers for the squares, and integers, squares, and and take some function take. Right. So I think seeing more examples would help us understand a little more. So let's create another iterator. So let's do definition. Integers. And we're going to initialize our value. So it's going to be a 1. And then we're going to do a while true. We're going to yield the value I. And we're going to increase this value I. Every single time we call the iterator, we're going to increase it by 1. All right, so let me comment this right here. And we're building. This is building an iterator for integers. So it's just going to return the integers without using a class. It's just using a generator. So let's clear this up. And you can see, oh, I never call it, right? I need to call the method int equals integers. And so I don't need to pass anything. It's just going to be calling the next element and the next element and the next element. We can make it stop at 5 if we want to, or we can iterate through my iterator. So in range, so I can say in range from 0 to 5, I can keep calling my next item on my iterator. So I can iterate through, we can iterate through an iterator. And I keep calling this next item over and over and over. Okay, so let's see this. So you can see we're accessing every single element through an iterator. That's if you want to access all of them at once. You can just call this method next of your iterator, right? Or we can access it one at a time. Let's do the next one, copy. And we're going to have squares. So what we're going to do is we're going to return squares. And it's practically going to be a for loop, right? Let's do a for loop of I values in the integers. So we're going to call this integers function that we have an iterator, and it's going to, we're just going to yield the value. So we're going to use an iterator for our iterator. So remember, by putting the word yield, it's going to wait for the next value. So this is going to be squares, right? We're making the squares, and we're going to call in this squares function or squares iterator. And we're going to range from 0 to 5, and we're going to pass in our squares. Let's call this squares. And let's see how that looks like. So we see 1, 4, 9, 16, 25. So remember, what we're doing is we're using the integers iterator to iterate through every single element. So this is going to go and grab every single element from 0 to 5. Is going to return the next value one at a time. Right, so let's do another one. So let's create this another iterator. So definition is take an n value and a squares as in a sequence. So in this case, returns the first n values from the given sequence. So we're going to return the first n values of the given sequence. So if we have this sequence is going to be equal to a iter. So we're gonna take this sequence and we're gonna turn it into an iterator. We're gonna call it the sequence. The result will be we're gonna put it into a list and we're gonna try we're gonna try it and catch an exception because we might get the stop iteration. So we want to make sure that if we do get that, we want to stop the system. We want to keep it going, so we don't want it to crash. And so we want to catch it. And so the result, we're gonna take the values and we're gonna append it to a result using the iterator of the iterator sequence. So we're gonna add one element at a time. And then if we have an exception, we're gonna catch it with a stop iteration. That's the exception would be we're just gonna don't do anything, we're just gonna pass it and return finally at the end we're gonna return the result. So we're making this sequence right into an interval so we can grab one element at a time. So we're gonna be grabbing one element at a time and adding it to our result. So let's see. We want to take let's print. We're creating this iterator for take, and we're going to call this take 5 squares. And you can see it's returning the 5 items, 1 square, 2 square, 3 square, 4 square, and 5 square. Since we're using this squares iterator that we have created over here. Right, so this is a combination of using generators within generators. So hopefully that gives you another taste of it. And so we have those examples. The advantages of generators. Why generators are important, right? They're easy to implement. Generate infinite sequence is very memory efficient, so you don't have to store every single element from your iteration. So you can just do one element at a time. That's very important sometimes, right? We want to be careful with our memory. How much memory do we have? So it's very, very useful. Very fast as well, because you don't have to go through every single element. You're just going through one element at a time. So the pipelining with generators. Without versus with generator. Without generator, memory consumes most of if the memory is consumed by the code. With the generator, the memory is efficient with the code, so that's very important. Without the generator, a constant implementation of the range. So you have to customize the implementation of the range with a custom range, with a custom implementation of the X range, and we can do this we can customize our range in a much more efficient way. 4 billion numbers would take 100 megabytes. 4 million number will take only 24 bytes. So you can see there's a big differences between if you actually implement it without the generator with the generator. So 4 million numbers will take 100 megabytes, while a 4 million numbers will take just 24 bytes, which is a lot better. Executions So the generator control flow execution suspends on encountering a yield. So it stops when it pauses your code, your function, as it encounters a yield. Execution resumes for the next iteration. So you can reach for the next element when you click the next item, the next method. Execution stops on encountering the return. So once you see a return, it will stop. Every generator is an iterator, but not vice versa. Generators instances are iterables. They can be used with an iter. So remember, we can every generator is an iterator, right? Remember, we took every generator and we made it into an iterator, but not all iterators are generators. A generator instance are iterables, right? It will make an instance of a generator. We can also iterate. We went through some examples, and we can use the iter to do that, right? I think we saw. You remember seeing that example where we use a iter in here. We use an iter to be able to create it into a iterable, right? So here we use the iter, the iterator into as an iterator. So we use the iterator as an iterable. Sorry, we use the iterator as an iterable. And so that's an example there of how we were able to use it. Okay, and then for loops works with an iterable, which must have an underlying iterator. An iterator, you can take an iterable and turn it into an iterator by using the function iter. It's called, which returns an iterator. The next of an iterator is repeatedly called until the stop iteration is raised from the next. Okay, so this is a very important tool to have to know is how to be able to use those iterators. Again, it's very efficient when you in the sense of memory consumption, and it's also very fast. So when we're dealing with a lot of data, it is important that we have an efficient process of information that is fast, that doesn't consume much memory, right? And so this is some of the advantages of using an iterator. And again, right, iterators are fast, are good. But of course, using a generator, right, we can make iterators a lot faster, right? We can make it a lot easier if we use a generator. We can make our own iterator using a class, or we can use the iterator function, but we can also make them using a generator. Okay, so this is a very important topic that in Python that it is very useful. Okay, so this is the end of the section. To make sure that you take this part that we wrote, right? I want you guys to please take this, copy paste it into your favorite file type, right? You can use a Word, you can use I think we have Notepad. If you have Notepad, you can use Notepad. Let's see. And so we can use Notepad and copy paste it there, or you can use Word. So copy, paste, right? And then you can save it, file, you can print it, right? And turn it into a PDF. And you can save it wherever you want to save it, right? And then use it to upload into the Canvas. So this is proof that you have read that you watched the video, right? And that you can use a Word as well. You don't have to use, you can use Word if you don't have Notepad or something like that. So you can just save it into Word. Right, so that's another way of doing it. It just doesn't come out as clean as using a text file. Okay, or like Notepad or TextPad. Okay, so if you're using Mac, you can there's a text there's a text editor as well, so you can use that one. But if not, then you can just use Word. Okay, and then submit it on Canvas as proof that you watched the video and you went along. Okay. All right, so I'll see you guys next time. We'll put the assignment for you guys to work on practicing using iterators. Okay. All right. I'll see you guys. Bye.